This is a demonstration of Lunar Crater Radio Telescope Prototype 5. In this demonstration, we're using the Lunar Crater model. Prototype 5 has a lift wire that goes through 3 to the payload and then to triangle 1, which acts as an anchor. Triangle 1, acting as an anchor, is anchored to the lunar surface at the rim of the crater. Lift wire 1 is unreeled as the lunar rover moves across the surface. The speed of robotic operations in space is very slow, deliberately so, but also because of relatively weak motors. As the lift wire 1 moves across the surface, at this point it becomes mostly suspended in space over the crater. Previously it had been rubbing across the surface. This might cause some problems with dust. At this point, the rover reaches anchor point 2. As the rover moves away from anchor point 2, both lift wire 1 and lift wire 2 need to be let out. Maintaining appropriate tension in the lift wires is critical to the operation of this prototype. When the prototype reaches the center of the opposite side from anchor 1, both lift wire 1 and lift wire 2 now need to be moved. Lift wire 1 is now contracting, lift wire 2 is still expanding. As the rover approaches anchor point 3, lift wire 2 continues to be released while maintaining tension in lift wire 1. In the real vehicle, the coordination between the tension in lift wire 1 and lift wire 2 and lift wire 3 would all be computer controlled using a closed-loop feedback system to maintain tension in the lift wires. As the vehicle approaches anchor point 3, the entire vehicle is anchored at anchor point 3. Lift wire 1 goes to anchor point 1. Lift wire 2 goes to anchor point 2. Both of those anchors act as pulleys. Lift wire 1 goes through anchor point 3, through the payload, over to the pulley at anchor point 1, and back and is tied off at the payload. It does not go through anchor point 3 a second time. Lift wire 2 goes through anchor point 3, through the payload, out to the pulley at anchor point 2, and back again tied off at the payload. From anchor point 3, by adjusting the tension in the wire, the lift wire 1, we move the payload out over the crater and closer to anchor point 1. Simultaneously adjusting the tension in lift wire 2 moves the payload closer to the center of the crater. In the final configuration, the payload is in the center of the crater, supported by the lift wires from anchor points 1, 2, and 3. Prototype 5A uses sewing machine bobbins instead of cardboard for the winders